Hi everyone, my name is Selena. I'm a developer advocate for GraalVM at Oracle Labs, and in this session today we will talk about rapid full stack development with JHipster, Spring Boot, and GraalVM. So a few words about myself. I'm Alina. I work as developer advocate for GraalVM at Oracle Labs, and Oracle Labs is this R&D facility at Oracle where GraalVM is probably one of our biggest projects, but also we are doing a lot of research in other areas as well. So in areas such as machine learning, compilers, security, all kinds of things. I also love open source and communities, and one of the projects that I like particularly is JHipster, so one of our topics today. Also, I like both programming and natural languages, and I'm a Ukrainian. I live in Ukraine right now and giving this presentation to you from Ukraine. So let's talk about building our full stack web applications. And there will be a few parts, a few pieces of this puzzle of how we build this application. And the first piece is GraalVM. So what GraalVM and what it can offer for us as Java developers, since I assume we are Java one, so mostly everyone in this room listening to this talk is a Java developer. So a few things. First thing is that GraalVM can give you more performance in JIT mode. So it is important to remember that in addition to various kind of unusual or innovative features, GraalVM is also a full-blown normal JDK that you can use to run your Java applications as you would on any other JDK in JIT mode. So in JIT mode, you would just replace your normal JDK distribution with GraalVM, and you will have all the same tools and libraries and IDEs available to you as with any other JDK. And the only thing that will be changing is the top tier compiler. So that is the highly optimizing compiler, and GraalVM has its own brand new, the Graal compiler, that for many and many workloads will give additional performance benefits. So that is one scenario in which you can use GraalVM, and that is to run your normal unmodified Java applications on GraalVM as a JDK. Now, another big capability or feature of GraalVM that could be interesting for Java developers is the native image technology. So native image is that component of GraalVM that allows you to take your Java application, compile it ahead of time into a platform-specific native binary that no longer requires a JVM to run. So what you can do with this binary is you can take it and deploy it onto a machine that does not have a JVM to run, and this application will be fully functional on its own. And in addition to that, it will also have fast startup and low memory footprint because it was optimized and compiled ahead of time at the image build time. So that is the second big component of GraalVM for Java developers. And last but not least, GraalVM is also a polyglot VM. So in addition to Java and kind of traditional JVM languages such as Scala, Kotlin, Clojure, you name it, GraalVM can also execute all those other languages such as JavaScript, Python, Ruby, R. And not only can GraalVM execute each single of those languages, but it can also execute polyglot programs. So programs written using any combination of those languages or any libraries from any of those languages. And it will give you this interop capabilities out of the box. But also on top of that, it will also give you the tooling and optimizations for the whole thing. So you can write fast, efficient, and highly performant polyglot applications on GraalVM as well. So that was a quick overview, and now let's focus on what GraalVM can give us as Java developers. So first, the choice that you get to make if you're using GraalVM is the way you would execute your applications on GraalVM. And as I said, GraalVM is also a normal JDK distribution, so you can execute your applications on GraalVM in a JIT mode, as we see on left here with your normal Java command. Now, what is interesting about GraalVM is that you get this totally new way of executing Java applications, and that is compiling them ahead of time into those native executables. So with GraalVM, you get to make this choice depending on what kind of performance, more specifically at runtime, you want to achieve for your applications. And we will talk about this in a second. But most of this session we will dedicate to talking about native image and how it can enable fast startup and low memory footprint for your applications. For the sake of giving you like full information, there is yet another way of executing Java applications on GraalVM. which is Java on Truffle. And Java on Truffle is this Java implementation on top of GraalVM's Truffle language implementation framework. So it's implemented in the way that we implemented JavaScript, Python, and all those other languages in GraalVM. But for the sake and the scope of this talk today, we will focus on those two JIT and native image modes, and more specifically on the native image mode. So let's talk about some more about native image and why it is so exciting, and more specifically for web applications, the kind of application that we are discussing today. So as I said, GraalVM Native Image enables compiling your Java programs ahead of time. And the purpose of doing so would be that your application would be compiled ahead of time, and all those expensive, heavy lifting operations would be done at the image build time. So when you run the application, it can run really fast and start really fast every single time you run it, because you already moved all those computation heavy operations to the image build time. And the way this works is that native image, when you build the application with the native image utility, will analyze the whole application and will try to find all the reachable code and compile it ahead of time to produce this final binary. And a great thing about GraalVM Native Image, so it's a great platform for kind of microservices and serverless applications, but also any kind of application that cares about startup or predictable performance or deployment to the cloud. And a great thing is that all of those Java microservice frameworks, such as, for example, Quarkus, Micronauts, Spring Boot, Halidon, they work really great with GraalVM Native Image, and they provide integrations with it, so you can easily build applications that you can then compile using GraalVM Native Image. So we will look at the examples in a second, but first I want to briefly talk with you about the idea of how it is even possible to compile Java applications ahead of time, and what is the idea behind it, and how it works under the hood. So what happens when you run our native image command and give it your Java application is the following. Native image will try to analyze your application and initialize it, and then perform snapshotting. So try to find all the reachable code and objects that need to result in the final binary for your application to perform what it's supposed to do. So the idea is to perform this kind of snapshotting ahead of time. And if we take a closer look under this process, what is happening is that native image will look at your application starting from its main entry point, and it will try to find all the reachable code. So all the code that is needed for your application to execute its functions, and only that code, so only the code that is kind of vital to your application's behavior, will end up in the produced binary. So native image would look for all the reachable code, but another thing it will do, it will also run initializations. And it will repeat those two things in iterations, so trying to find reachable code and run initializations until it has all the necessary information, all the code and object information available to produce your final compiled ahead of time version of your application. So in the end, what you will have in your resulting binary is your application code, but also pre-populated heap. So native image will also pre-populate your heap so that you can start really fast and really efficiently, because all this hard work has already been done at the image build time. And one more benefit of such approach is that native image would also eliminate all the code that you are not actually using. So if you are pulling some random dependency or something that you're not so sure about, that you almost don't use at all, native image will only include the parts that you are actually using in your final produced executable to make it more efficient. Okay, so that is the idea behind native image, and now let's look at how you can actually benefit it and how you can use it from various frameworks. So some time ago, the Spring Boot team announced that they are integrating native image into Spring Boot, and this was in March last year that they announced the beta release of Spring Native. And since then, they've done a lot of work to integrate native image into Spring Boot. And the outcome is that at the moment, you can just go to start.spring.io and generate your new Spring project and include the support for native image. It's called Spring Native as a dependency. So this is the way you would, for example, get started if you want to build a Spring Boot application that you would next compile as GraalVM Native Image. This is fairly easy for you to get started. And to give you some motivation, why would you care about this? Here are some numbers. I believe this is from Sprint 1 last year. So it was still kind of work in progress integrating native image. But even here on those examples from a while ago, you can see how much faster and how more efficient the container image size is when running on native image comparing to running on the JVM, right? So if we look at all those applications, we see that when running on the JVM, it takes some time for the application to start, right? Because we know that there are a lot of operations to be done when your application is actually first starting when you're running on a JVM. So it would need to start loading classes, start interpreting, compiling, profiling, and then initially it will warm up and will run with the absolute best performance. Now, comparing to that, you see how much faster and also smaller the native image applications are. And to give some examples of what you can already accomplish, as I said, you can just go and start with the start.spring.io, but also here are some sample applications from the Spring Boot team that are working great with native image. And you can see that there are a lot of things, such as, for example, Kafka or the Pet Clinic application or Native or Tomcat that are working really great. And you can use all those technologies and build your application as GraalVM native image. And to illustrate that thought, I want to show you a quick demo of a Spring Boot application that I have on my machine. And it is already compiled as GraalVM native image. So I'm in this folder, and let me actually show you the app. Not this one, this one. So here I have my Spring Boot application, and that's basically a simple web server. And if I look at it, I see that it's a normal Spring app. And when I go ahead and run it, and I already have it compiled here as the native image for the sake of saving us all some time at this presentation. So I already have it compiled as native image. We see it here, and we also see that it's quite tiny for the fully compiled, fully self-contained application. So it's a native executable, and when I run it as a native executable, I see that it starts, and it starts in 0.5 seconds. Probably could have been even faster, even if I haven't so much stuff running on my machine right now. So it started, and just to verify that it's working and performing correctly, let me just get the right Chrome window. So I can go to localhost 8080, and I see that my application is up, and it's saying for me hello from Spring MVC and Tomcat. And if you paid attention, so it started really fast. It started in 0.5 seconds. So this is something you can accomplish for Spring Boot applications when using GraalVM native image. So let's just go back to the presentation, and let's look at the final piece of our puzzle, and that is JHipster. So JHipster is this development platform that allows you to easily build, develop, and deploy applications. In particular, it's really great for microservices and web kind of applications. And it will give you a lot of different Java frameworks on the backend, along with a really nice, modern, mobile-friendly UI. And a few more reasons to be looking at JHipster are the following. So one is that there is a great open source project with a very active community. Its development is happening on GitHub, and it's really close, I believe, to hitting 20K stars. So if you haven't yet, please go ahead and give it a star. It will help project a lot. So in terms of what kind of technology it gives you for the backend, you can use something like Spring Boot, Quarkus, or Micronaut, really a backend of your choice. And along with that, it also gives you plenty of options for your front end. So it could be things like Angular, Vue, React, again, depends on your choice. And as it generates code for you, it also applies industry's best practices for your project and gives you plenty of options for cloud deployments, gives you things like authentication and user management out of the box. And also what's great about it, your application, in particular your Java backend application, can start really fast thanks to the integration with GraalVM native image. Okay, and talking specifically about GraalVM native image, so some time ago, the JHipster team, and in particular Matt Rabel, had this announcement about introducing this Spring native support for JHipster. Thanks to the team for working on this. And the way it works, here I will give you an overview, is at first you would need to install this generated JHipster native blueprint. then run it. So by running the JHipster native command, and what this will do, it will run the wizard that helps you configure your project, where you're answering different questions about what kind of technologies you want to use in your project, what features you want to enable, what should be the structure of your project, things like that. Then you would package it as a normal Spring native application. And then in the end, you can run it as a native binary, similarly to how we were running this Spring Boot application a few minutes ago. So that is the steps. If you want to follow them, I encourage you to give it a try and share your feedback with us. And now I want to show you how it is working in practice, and in particular, show it to you on my machine. So if I go to my VS Code, and here is my JHipster project. So if I look at the application, I see that this is a normal Spring Boot application, and JHipster generated a lot of files for me. Those are my backend files. I have some files for front end. I have my Docker files, everything basically I need to deploy my application. And to give you an idea of what kind of application I have here, let's look at this configuration file. And this is similar to the questions you are answering for the wizard when you're first configuring your project. So this particular app that I have here is a monolith one, could have been a microservice. I'm using JWT for authentication. I'm using this JHipster native template that is leveraging Spring Native under the hood. For the front end, I have Angular, and yeah, my JHipster version, what is it, is 7.9.2, and the rest of my configuration. So again, I believe I have this file compiled already, so let's run it. Okay, not this one, this one. So I have it already compiled just to show you how quickly it can start as a native executable. And now let's start it. So it's up on the port 8080 again. And again, to just emphasize the startup aspect of it, it started in 101.4 seconds, but could have been much faster if, again, I didn't have so much stuff running on my machine right now. But it's up. So let's look at this application. So again, it's on 8080. And now as I update the page, I see my JHipster welcoming page with all the resources where I can get additional help, talk to the community, and so on. And when I log in to my admin interface, so I see that Chrome is warning me that admin is not a very safe combination of login and password. But when I close this, I see that my application is up and running, and I can add more users here. I can add entities, so start building up my application. So I have this perfect base for starting building up my web application. And as you saw, it started in under like a bit above 1 second, but could have been really also under 1 second. So really, really fast, and it's ready to be going, and you can start building your website or your web application out of this base app. So this is really great, and this is how this integration between JHipster, Spring Native, and GraalVM is working. So to go back to our presentation, here we were leveraging Spring Native, but just to give you like a full information about JHipster, you can also use other frameworks. So if your preference is to use Micronaut or to use Quarkus, you can also do this and still use those frameworks with JHipster. And another cool thing from JHipster, so in this JHipster ecosystem, they now have this new JHipster Lite project that is supposed to be a lightweight, a kind of new version of JHipster. And there they are also working on GraalVM support. So really looking forward and very excited about this new project and GraalVM support in it in particular. So that is it. And I also want to use this opportunity to talk about some other updates that are there in GraalVM and in Native Image specifically. So one thing is that we have those great Gradle on Maven plugins. So if you are looking to start building your first Native Image application, I encourage you to take a look at our Gradle on Maven plugins. You can also find them on GitHub by looking for native build tools. And what they will do for you, they will significantly simplify building and running your applications as native executables. And also one of the things that they will do for you, they will also help you out with testing, and in particular JUnit 5 testing. So if you want to build native image applications, I do encourage you to give our native build tools a try. And another exciting news, this time from our partners. So there are new additional debugging capabilities coming up in IntelliJ IDEA and particularly in the early preview builds. So this is enabling debugging native image applications right in your IntelliJ IDEA, which is really exciting, really looking forward to it and trying it out in practice. And another great thing, so one of the topics that we are working a lot in the native image kind of area of GraalVM is improving developer experience. And one of the things we did there is this new quick build mode. So this is intended specifically for development purposes. But if you ever try to build a kind of bigger Java application with GraalVM Native Image, you could have noticed that for a bigger application, build times can be quite long because native image needs to analyze your entire application and all of its dependencies to figure out what has to be included in that final binary. So having that in mind, for bigger projects, it can take longer time. So to help you out with that, we introduced this quick build mode in native image that is only intended for development purposes, and you can enable it with this OB flag. And this way, it will speed up the build time significantly at the cost of the performance of this binary at the runtime. So what you would get faster build times, but at the runtime, your application would not be as performant. So we do recommend this option only for development purposes as you're developing your application and you want to get faster results, faster feedback from native image about how your application builds. But then as a final step in your development process, you would build your application with the normal native image build mode to ensure the best possible performance at the image runtime. And another interesting and very important update in the native image ecosystem is that we now have this new GraalVM Metadata repository. And this repository is this centralized space, which is a GitHub repository from GraalVM team, where different ecosystem partners, library authors, and native image users can contribute and then reuse metadata needed for a native image to work with your applications. So this is helpful to make more libraries in the Java ecosystem work with native image out of the box. And the way this works is that different users can contribute metadata needed for native image to figure out how to build your application to the centralized repo. And then when you're building this application that leverages, let's say, some particular library, by enabling access to this metadata repository, you can pull this data about your library configuration automatically from this repo, simplifying this configuration significantly for you because this metadata could have been already figured out and contributed by somebody else to this centralized repo. So this is a very important community project. Actually, let me go ahead and see if I can very quickly open it for you to show what is happening there. GraalVM reachability. Okay, this is it. So this is the repo, and we are working on it together with our partners, so with people from the Spring Boot, Micronaut Quarkus teams. And here you can see a lot of metadata already contributed, for example, for things like, I believe I saw a Hibernate somewhere here. Here it is. For MySQL, for PostgreSQL, for H2, all kinds of things. So this is the place where different users and maintainers can contribute metadata so that others can reuse it and have simplified configuration for different libraries to work in the native image mode. So this is another exciting update that I wanted to share with you. And I wanted also to talk a bit more what is coming next for GraalVM Native Image. So we will keep working together with our partners to simplify this configuration and compatibility for Java libraries, more specifically in the native image mode. We also want to make sure that native image performs on par with the OpenJDK. So performance optimizations at runtime is another priority for us. And we are working closely with all those framework teams, so Spring Boot, Quarkus, Micronaut, Halidon, to ensure that their users can leverage and benefit from all the latest native image features. We will keep working on this quick build mode and other native image improvements and making sure that you can have access to all the native image features in your favorite IDE. And another thing is we will keep further improve the performance of GC in native image as well. And if you want to follow more closely what is coming up next for native image and what is coming next for GraalVM as a project, as of recently, we also have this public roadmap on GitHub where you can see how we are working on different features and which release those features will land in as we are working on them. So if you're curious what is coming next for GraalVM, go ahead, go to our GitHub and check out this GraalVM community roadmap, and it will give you an overview of what is coming next in each of our releases. And we will also appreciate your feedback on any of those features. So if they are exciting for you, or if you see some improvement areas, you'll really use your feedback as well. So to summarize all of this and how to get started with GraalVM, the best place to get started with GraalVM would be our website, which is graalvm.org. It's the place where you can find all of our latest tutorials, guides, reference documentation, and also where you can get our builds, so both for Community Edition and Enterprise Edition. Or if you are an SDK Man user, it's even easier for you. You can very easily install GraalVM with SDK Man as well. And talking about JHipster, so just to reiterate the steps to get started with JHipster Native, you would install the JHipster Native generator, you would run the wizard, configure your project, build it as native image, and benefit from having your application start really fast as GraalVM native image. And if you want to learn more about JHipster, just go to their official website, which is jhipster.tech. And there you can find a lot of community resources, tutorials, and everything basically you could need to get started. And also it's the place where you can support JHipster by backing it up on Open Collective or in any other way. And that is it. That's all I had for you today. So here's again my name, my Twitter handle. If you have any questions at all, my DMs on Twitter are open and I will be happy to answer your questions or just talk with you about GraalVM. That's it. Thank you.